Much from Be My App. Thank you for being here. And most of you must already have received an email from me, from Michelle, or from Sandra. So we just want to say thank you for being here, and I would like to introduce you to Peter Dunkley, who will be speaking and introducing you to this webinar. So, Peter, you can speak now.
Hello, my name's Peter Dunkley. I'm here with Andrew McGough.
Hello.
We're from Acision, and we're here to talk about the Acision Forgeathon today. So, as I'm sure you all know, because you've come to this webinar, the Forgeathon App Challenge is live today. And as part of this, we want to help you take your app global. So, what we're inviting you all to do is to create a project based on our Forge SDK, and you could be in the running to win a stage at this year's global tech events, Mobile World Congress and South by Southwest. So please submit your app. So as I mentioned, my name's Peter Dunkley. I'm a technical director here at Acision. I'm responsible for the overall architecture of the Forge SDK. And this is Andrew McGough, who's a senior architect in the team working on the Forge SDK. So for those of you who don't know, I'm just going to spend 2 minutes giving a bit of a background on Acision. So Acision at a glance, we're the #1 messaging provider in the world today. We've got a 20-year plus history, and we route more than 2 trillion messages a year. And we're a global company with 35 offices across 6 countries, 650 plus employees, and a large support team. We were the first company to launch an SMSC. That's the piece of infrastructure that goes into mobile networks to enable the routing of text messages. And today, we also offer cloud and virtualized services, as well as advanced messaging capabilities in WebRTC. So I'm going to start just by giving a little bit of history about WebRTC and about the shift that's currently going through communications today. So a lot of people ask whether WebRTC and the developments that are happening today are evolution or revolution, and I contend that they're both, because if you look at the history of the World Wide Web, we started with static pages in the early 90s, through to dynamic pages, through to applications that actually run in the browser, web apps, through to applications today using technologies like WebRTC that enable real-time communication between users. And this has been a very rapid revolution. It's hard to imagine today, but only a quarter of a century ago, the internet as we know it didn't really exist. The World Wide Web didn't come into existence until 1990. But if you look at telecommunications, this is a real revolution. Telecommunications has taken 250 years to do what the World Wide Web and the internet has done in a quarter of a century. And the big difference between how telecom started and where we are today is that if you look at things like the optical telegraph, which was used by Napoleon to direct his armies across France, or if you look at electrical telegraphs, which required putting wires across a continent, or telephone systems, these cost billions and billions and billions of pounds to build and install. It's something that you could really only do as part of a massive organization, or as part of a government. And where we are today with things like WebRTC and the revolution that's occurring in communications is that you don't need that kind of infrastructure and you don't need that kind of backing to build something now. There's been a real democratization of this industry. And what we as Acision are trying to do is help developers get in there and take advantage of all of these advances. And basically what we're talking about is RTC Web and WebRTC. And a lot of people get these confused. So RTC Web is simply the stack. RTC Web is being defined by the IETF, and it defines what goes over the wire, what the bits are, all the way through to what kind of encryption do you use, what codecs do you use. And the idea is that by providing this single definition that is secure, that is peer-reviewed, that is well put together, it makes it very easy for very different people to write applications that can interoperate like browsers. And with WebRTC, well, this is what the W3C are doing, and that's about providing an API, the JavaScript API, that goes into the web browsers to enable people to use these real-time capabilities. So what is Forge by Acision? Well, with Forge by Acision, we have taken WebRTC and a variety of related technologies and pulled them together into a single SDK, which means that you have a single SDK with an API that will run in your browser, that will run in Chrome and Firefox, and that will allow you to do rich communications, video, audio, video, messaging, presence in a browser, but also in a mobile app. You can build native applications as well. And what that means is that with Forge by Acision, you can write a native application on iOS and a native application on Android and a web app, and they can all communicate with each other. You can make calls between them, you can send messages between them, you can transfer files. And why would you do this? Well, it allows you to revolutionize a whole range of sectors, healthcare, banking. All of these call center type things can be enhanced. Or what about online dating? You know, you can have easily build an online speed dating service, or you could use this as part of a real estate application to show a house. You're wanting to view a property and you can't get down there, so the estate agent can show it. Or as Amanda was involved in at a recent, who's also on the call but quiet right now, at a recent conference, you could do an application where you get dietary advice, where you can have a personal shopper going around the supermarket selecting your goods for you. There's a wide range of opportunities that this technology opens up. And so basically, Forge by Acision is a smart communications framework. So as I've said, click to call, video chat from a website, whether it's call centers, healthcare advice, anything. Contextual information. This is really, really important. If I'm logged into my bank and I want to query a transaction, isn't it great if I can just click a button, go straight through to an operator who already knows what I am because I've logged into the bank, who already knows what I need help with because I clicked on a button next to the transaction I'm querying. You can massively improve the user experience of these mundane services. And even better, for the company that's delivering it, you can save money. Because by doing this, you can shave minutes off of each phone call into your call center, and that means you can do more with less people. So that's my quick introduction to what Forge by Acision is. And now I'm going to hand you over to Andrew McGough, who's going to actually, while we're in this webinar, go through building some apps right now, just to show you how easy it is to do this quickly.
Okay, hello. So, the main thing I'd like to try and get across in this webinar is just how easy the Forge SDK makes it to create messaging, presence, video, and voice applications that are completely cross-platform. They cover Android, iOS, and the web. So in this webinar, I'm going to try and create a simple Android chat application, connect it to a compatible iOS chat application. Then I'm going to show you how to create a HTML WebRTC application, which does audio and video. And then I'm going to modify the original Android application to connect the video to the video that's output from the web application that I've just developed. So that's quite ambitious to fill all that in, you might think, but we'll do it. Right, so the first thing you need to get started is to get a Forge SDK account. Now, if you do that, you'll get through to the Forge website, and this is what it looks like. Now, if you can see where I'm pointing, that is one of the key pieces of information you need there. That's the API key, which is unique to you, and you use for connecting to the Forge network. And if you click on the View User Accounts button, you'll get a list of 10 user accounts that have been assigned to you for development. This is just for developer users. So you'll get 10 accounts and 10 passwords. I've obviously blocked out the passwords for this presentation. Okay. This is a flow chart of the internals. We won't concentrate on that too much. And if you click on the downloads button on that web page, you'll get to this page, which is where you actually download the SDK. So as you can see, you can download the SDK for Android, iOS, and for JavaScript, which is obviously for web. There's a whole bunch of demo applications, and you can also get to the documentation through this page. Okay, so I'm going to start with Android, as I said, an Android chat application. So basically the first thing you need to do with the Acision SDK is connect to the Forge network. And this simple piece of code is what you need to connect to the Forge network on Android. So if you look at the top line, that's where you put in the API key, username, and password, which I showed you on the web page. There's a little bit of configuration just to say that we want persistent connections. And then you basically set up a new Acision SDK, and you set up some callbacks so that when the Acision SDK connects, we display that it's connected on our Android application page, and then start messaging. So that's all you need to do to connect to the Forge SDK network on Android. And then the rest of our app, to do this chat app, we just need two more functions. One is to set up the callbacks for testing messaging, which effectively receives a message and displays it on a view on the Android application. And the other is the do send function, which is linked to a button on the application and actually sends a message. So as you can see, there's very little code there. Most of the code that is there is actually updating the actual controls on the actual Android app. And these are the steps you need to go through to create the app, which I'm going to actually do now live. Okay, so I'm going to escape from that. Open Android Studio, which is the latest way of developing Android apps. We're going to create a new Android Studio project. We'll call it Test Chat App, for instance, or Chat Test. Accept the default version of the API. We'll just do a blank activity, and we'll just accept the defaults for that. And hopefully, it should create us an application. So it takes a few seconds for Android Studio to create the basic application. Right, there we go. So, okay, close that. So it creates a basic hello world application for you. And the first thing we need to do is actually get the Forge SDK libraries into the actual application framework. So these are what you get from the downloads web page that I've already shown you. So basically, if I open, you get an SDK zip file. So I'm going to copy the jar files out of that. Copy the two jar files. Go back to Android Studio. And they go into, it's best to go to the project view so that you can get a clearer view of the application from there. And they go into a folder called libs. So I'll paste those in there. Okay. Then you need to right click on those and say that you're going to add as a library to the application. I think you only actually need to do that to one of them. And then I need to copy the native libraries, which are the kind of the underlying WebRTC libraries that the application uses. So to do that, you create a folder under main, okay, called JNI libs, new directory, JNI libs, okay, and we're going to copy these two folders into there. Okay, so that's now got the libraries added to the Android application. So another thing that we need to do is we need to update the Android manifest file, because as this is obviously doing network communications and also accessing webcams, we need to give the application permission to access those things, which is a standard Android thing you're going to do. So I've got some code I can paste into there. So it's just 4 lines to say, give this application permission to access the internet, the camera, network status, and to record audio. So I'm going to paste that into the Android manifest file there. Okay. Now, let's have a look at the layout of the application that we've got by default. So the default layout for an Android application is a hello world is what you get by default. Obviously, that's not what we want for our chat application. So I've got some, to save time, I'm not going to draw this manually. I'm going to actually just import from a file that I've already created, and I'll talk you through what it actually does. Replace the hello world one. So basically that's what it's going the controls look like. So it's basically a text view which tells you the status of the application, which is going to start off as connecting, a text box where you type in the destination you want to send to, a text box where you type in the message you want to send, a button which is going to actually send the message, and then a scroll view with a text view in it, which is going to show you a list of the messages you've actually received. And so if you look at that, that's what it's going to look like. Finish that. So just with that small amount of XML defines that. And you would do that yourself by actually dragging the controls into the actual window here. But I've kind of just imported the XML file to make it a bit quicker. Okay. Now, the next part is to actually get the code in there. So if we look at the Java file that's been created, that basically just opens the basic Android activity. Now I need to put in there the code that I've just shown you a minute ago on the slides. So that got stored in another text file here. Okay, so it's basically this piece of code here. Just going to cut and paste that into the top of here. So that's the bit that connects to the Acision network, as I said, and that's the bit that does the send and test messaging, as I showed you on the slides. And now I'm going to call the start method when the activity opens up. So I'm going to call start there. Okay. Now, as you can see, there's a whole bunch of non-imported methods there, and I've got so to save time, I got the import lines that I need there. You can actually get them manually by just doing Alt-Enter, but saves a bit of time to just paste it in. Okay, so most of those should disappear. There's a couple still left that I've obviously forgotten, so I'm going to quickly add those using Alt-Enter. That should be it. So things are looking green, so it's looking pretty good. So now, as you can see, I've actually, the API key I've used is the one that was originally on my web page, and I'm logging in as the user called Andy Forge, Andrew McGough, com0. So I'm now going to try and run this application in the simulator. Hopefully, I've got the simulator open in advance because it takes a little while to open. I'm hoping it's going to compile, and then I can run it. Okay, so it's found my simulator. I'm going to run it in there. Here we go. Starting up. Okay, so as you can see, it's connecting to the network, and now it's connected. So that means it's successfully connected to the Forge network. So I'm going to try and send a message to itself. That's the only thing I've created so far. Oh, this was the username from earlier that was on the web page. So I'll send it a hello message. As you can see, it said there's been a message received from Forge, Andrew McGough, com0, and the message is hello. So that's worked, basically. Okay, so go back to the slides quickly. Skipped a bit there. Okay, so how do I open that one? Okay, right. Okay, so that's basically the app that I've just created. Okay. So the next step. Does anyone have any questions at this point? I'm happy to take questions on the Android bit if anyone has any. I'm about to move on to the iOS version of the same app. Okay, I'll carry on. Okay, so now I'm going to do the equivalent in iOS. So this is pretty much identical code to what we did in Android, but for iOS. So it opens the SDK, you pass it the API key, the username, the password, and then you wait for an on-connected event, which comes back through an Objective-C delegate. You display that you've connected on the actual application screen. You get access to the messaging part of the Forge SDK and set a delegate so that you will actually receive messaging messages. And then there's equivalent bits to what I used earlier in the Android SDK. So there's an on-message received callback, which gets called when the message gets received, and it puts it into the control for showing received messages. And there's a send pressed, which is linked to the actual button on the actual application, and will send a message when you click it. And these are the steps you've got to go through to create an application and get it running under Xcode. So they're all quite small steps. I'll actually do it now. Right, so I'm going to open up Xcode. Create a new Xcode project. I'm going to do a single view application, because just to keep things simple. It's worth saying that normally when you do an application like this, you'd probably put a login and a password box to start with, but I'm just hard coding that for this app to keep things simple and to actually be able to do it within the time, but that's what you probably normally do. I'm going to type in a name for the application. I'm going to call it iOS Chat App. Next, I'm going to save it where just in the default place that it suggests. Right, so iOS has created me a default project called iOS Chat App. Now, similar to the Android thing, the first thing I've got to do is actually get the libraries into the project. So the best place to go on there is to click the iOS Chat App at the top there, click the project there, go to Build Settings, and type header. Header. I think it's additional header directory, something like that. A header search path, that's the one I'm looking for. Okay, so I need to add to that, and I'll just find the folder that I need to add to it. So if I know I've copied the headers from the zip file you get from the website to a folder in my documents folder. So I just pick one of the headers, do a get info on it, and that'll give me the directory name there that I need to paste in. So I'll paste that into there. Paste that into there. And then I've also got to add a library search path to pick up the libraries. Library search path. So I'll add that into there. And that's basically the same, but with libraries instead of headers on the end of it. It's all pretty straightforward. So that gets into there. And then I've got to actually, right, now I'm going to add the libraries themselves to the target project. So libraries. If I open the libraries folder, that's all the libraries I need to add from the Forge SDK. So I can paste those into there. And there's a couple of extra libraries you need because the WebRTC libraries depend on it. So I'm going to add those here. So there's GL kit, which is for the OpenGL side of things. And there's the ICU core, which is some user interface stuff, I believe. There's libc++ because it uses C++ behind the scenes, the WebRTC library. And the final one is libsqlite, I believe. Add all of those. And then there's also one final thing I've got to do to configure it, which is to add a linking flag. And this is so that we can get access to all the everything. Flags, additional link, I think it's called additional linking flags, other linker flags, that's all. So I'm going to add to their -opc, so that's so they can get hold of all the symbols it needs to be able to compile the application. Okay, and I think that that's the main steps I need to do before I can actually start creating the app. Now, so the main things I need to update are the view controller, which, well, basically when you create a single view app, everything is driven from one view, which is kind of the code for that's in the viewcontroller.h and the viewcontroller.m. So I'm going to add some code to that. Okay, I'm just going to find my problem again. Right, so this is the viewcontroller.h. I want to open it. So this is basically exactly the same as the original one that's already there, except it adds a few delegate classes to it so that we actually receive the callbacks for the various SDK methods that get called. So take that. And then the controller.m. We actually need to do that. Controller.m. I'm going to paste in that as well. So this is basically the same code as I showed you on the slide. So there's a loading function which sets up the SDK with the username and password. There's a connected callback which sets up messaging, and there's a send pressed handler. So that basically is the code behind it, but we haven't got a layout for the actual app page. So I'm going to create that now. I'm going to just quickly do that manually this time. So I put a label at the top, which is where I'm going to display the status. Put that up here somewhere. I'm going to put a text box, which is where I'm going to type in the actual destination for the message. Put in another text field, which is where I'm going to put in the message that I'm going to send. Then I'll put in a button, which will be the send button for the application. Put that in there. And then I'll put in a text view, which should be where I actually display the text itself that gets received. Okay, and now if I just need to minimize slightly. It's a bit too wide. Right. So the label I'm just going to put, I'm just going to put connecting in there, which is going to be the initial status that we get. I'm going to put a bit wider placeholder. I'll put destination in there, so you know what you're going to put in, type in there. Message is the placeholder there. Send is the text for that button. I'm going to clear out that so you can't see anything there. Okay. So turn on the assistant view, which means I can see the code and the actual controls next to each other. And I can have a quick preview of what that's going to look like when it runs on a real device from there. So I'll make these a little bit wider. Okay, so that will do. So I've got that, and now I've got to connect these controls to the actual code itself. So I go to viewcontroller.m, and I just have to, all I do is I right-click from there to the actual correct control. So that one I want to be my status. That one I want to be my destination. That one I want to be my message. That box there I want to be my chat list. And the send button, I want to link that to the send pressed event down here. So hopefully I look at those: chat list, send pressed, message, destination, and that should be it. That should be an iOS application, which is the same thing as the Android application we created earlier. So I'm going to try and run that now in the iOS emulator. It's just taking a little while to load up. Okay, here we go. I'll bring up the Android one alongside it. Okay, so I'm going to start. So it's connected to the SDK network, Forge SDK, and now I'm going to try sending a message to itself. This is COM1, I can set this one up as, and I'll try to send a message to it. And as you can see, it's actually received the message. Now I'm going to try sending a message to the Android version of the application, which I can do by just changing that to a 0. Now hopefully it should appear in this Android window as soon as I do this. And there it is. So the iOS app sent a message straight to the Android app. So back to the presentation. So that's pretty much it for creating an iOS and an Android chat messaging app.
Okay, we've just had a few questions come in, so I'm just going to go through the questions we've had so far, and then Andy will continue with the presentation. So the first question from Romain Pellin is: the hands-on tutorial provided with the SDK is quite basic. Didn't find tutorials over the web. Is there any, especially for iOS? Can we get these presentation slides? So these slides will be available, and we'll be providing them to Maud at the end of this presentation. There are also some tutorial videos available on YouTube, with more going up all of the time. And we'll make sure that you get a link to those. There's a question from Joseph Romero Garcia. would it be possible to use JavaScript SDK and pack all with Cordova instead of those Android, iOS, etc.? And the answer to that is not at this time. There's no Cordova support at this time. It says, any way to securely store the auth details rather than config? Well, yes, as Andy mentioned, he's put in the username and password hard-coded into the application for speed there.
Yeah, you wouldn't normally do that.
You wouldn't normally do that. You would normally have a user enter their own username and password to use the app. Somebody's asking, where did you get the code for the messaging? Well, again, this presentation will be shared afterwards. That was from Alice Usachev. Another one from Romain Pellin, is PushKit required, which is iOS 8 only? PushKit is not required. You can write WebRTC applications to receive calls without PushKit, and that will work on both iOS 7 and iOS 8. But we also do support the use of PushKit on iOS 8, so you can write your application in a more efficient way. Okay, and there's been a couple of other questions about the presentation, and yes, there will be copies of the presentation made available. So I'll let Andy carry on now with the next part of his demonstration.
Okay, so that basically shows you how to set up a simple chat messaging app that covers both Android and iOS. So I'm now going to move on to showing you how on a web page you can do exactly the same thing, connect to the Forge SDK. This time we're going to try and do WebRTC video rather than messaging. So I'll show a few slides for that to begin with. Okay, so this is the basic HTML for the application. So these 3 lines basically just import the libraries that I'm using in the application. So I'm using jQuery to make it easier to manipulate the kind of underlying DOM of the HTML page. That's the SDK JavaScript library there. I'm using underscore to make a few operations simpler too. So this is the body of the body of the HTML page, and it looks a lot more complicated than it is. It's just a simple top-level div. Inside it, there's an audio tag, which is what actually plays the audio for the web page. And then within that, there's a span, which is what I'm using for displaying the status. So I'm updating this to show the status as the call's going on. And there's 2 buttons. Now this app, I've made it so that you can actually connect as 2 different users. And the idea behind that is you can open the page twice on the same computer as a different user, and then you can make a call from one to the other just for testing purposes. So that's kind of why I've done that. So there are 2 buttons, one to connect as user 1, one to connect as user 2. There's 2 video tags. This is where the remote video is going to be displayed and where the local video is going to be displayed. Then there's a simple text box, which is what I'm going to use to type in the destination when you want to make a call. There's a button to actually do the call, and there's a button to disconnect the call. So as you can see, it's just a fairly simple user interface defined in HTML. Right, so this is the equivalent of what we've already done in Android and iOS. So it just connects to the Forge network. So it's kind of equivalent APIs, but in HTML, sorry, in JavaScript, as opposed to Objective-C or Java. So you basically set your username and password. Again, I've hard-coded them. There's 2 in this app because you can connect as 2 different users. Then you call this to create the SDK connection. This is the callback you get when you connect. And inside this callback, I've actually, this time around, I'm actually setting up a WebRTC callback. Now what that's actually doing is that's setting up a callback when you actually receive an incoming call. That could be video or audio or both. Right, so this is the only bit of extra JavaScript you need to be able to handle an incoming call. So this is the callback from the previous slide. So as you can see, I set up a callback on incoming session when you receive a call. This is the on incoming session function. So it basically receives the session, updates the status to say there's an incoming call. So that's just the actual div that was on the span actually that was on the web page. Then it feeds in the incoming call into the video and audio tags that we set up on the page. So it finds those here and then updates the object that gets returned. And then it sets up another callback when the call gets disconnected. Now this is interesting. This line accepts the call. Now normally in most applications you wouldn't accept the call at this point. You'd actually make a ringing noise and then the user would take an action to say accept the call. But to keep things simple, I'm accepting the call at this point. So it essentially answers straight away without a kind of ringing period. But yeah, that's just to keep this demo simple. And this is to handle outgoing calls. So this function is linked to the button to send a call. So it basically reads the destination from the destination text box. And it does an outgoing WebRTC connect. And this sets up a few callbacks when it connects. And then it says that I want to do audio and video in the call. And it connects the audio and video from the call to the tags in the web page, similar to what we did when you receive a call. Okay, and this is what it looks like. So I'm going to go to that now. Okay, so open that in Chrome. Actually, I can show you it in the. I'll show you it in the IDE first. So before I do that, so I'm using the just standard Eclipse with a couple of web plugins to actually edit the web page, and I'm using Python as a web server just to serve the pages. So just opening Eclipse. I'll open the web page at the same time just to keep things going. That's one copy of the web page. I'll shrink that down so I can put two alongside each other. And I'll duplicate. Over there. So that's two web pages. So these are the tags that you saw in the HTML. There's two buttons to connect to two different users. There's two video tags for showing one's local and one's remote video. There's a text box for typing in who you want to call, a call button for making the call, and a disconnect button for disconnecting the call. And this is just the code. It's pretty much exactly what I showed you with a little bit of setting up the controls on the web page when you start up. But other than that, it's pretty much identical to what I showed you earlier. So there's just the body there. Okay, so I'm going to try it out. So connect as user 1. Connect as user 1. So it's connected to the SDK as user 1. I'm going to connect this one as user 2. So it's connected to the SDK. I'm going to now these two are set. This one's set up as user 2, and this one. Sorry, this one's set up as user 2, and this one's set up as user 3. So I'm actually going to do a call from user 2 to user 3. So these are my usernames from the original Forge SDK page. Com3. So I hit the call button. Now the web page is telling me that it wants to use access to the camera. This is something that's built into Chrome for WebRTC. It doesn't let you use the webcam without asking you for positive confirmation first. So I've done that. Now the far end is saying it wants to use the camera too because it's receiving a call. So I'm going to allow that. As you can see, they're both using the same webcam because they're on the same PC, but you can now see the audio from one to the other. And I can obviously disconnect the call from that button. Okay, so that's basically how to set up a simple video call just using JavaScript and HTML. I can take some questions now before I move on to actually adding that to the Android version of the application. What are the username and password?
So when you log on, when you create yourself a Forge, this question is what are the username and password from Romain Pellin? When you create an API, when you sign up to the Forge portal and create an API key, you'll get some development usernames and passwords that you can use. Is there support for developing the Android version in Eclipse? The answer is yes. As you saw there, Andy just created a brand new Android Studio project and copied the libraries in. You can do the same thing in Eclipse if you want to. It said another one here saying from C Chen, the Great Firewall of China still work? The answer is, I honestly don't know. All of the signaling and media, sort of the signaling connections and things that go over here are over HTTPS and WebSockets, secure WebSockets. So it's all encrypted over the normal ports you would go over for web traffic. Media for WebRTC is encrypted over UDP. Whether that works through the Great Firewall of China, I don't actually know. How to set the bandwidth requirements for WebRTC?
Yeah, there are some constraints you can assign when you set up the session, which would control kind of the maximum video resolution, minimum video resolution, and things like that, which you can use to restrict the bandwidth requirements. It also negotiates down. The WebRTC stack itself monitors the bandwidth between endpoints and negotiates the quality of the video down automatically to compensate for that. So it's kind of inbuilt into WebRTC as well.
And you'll find information on how to actually set those constraints specifically in the API documentation for Android, iOS, and for JavaScript. So it's slightly different depending on which platform you're developing for, but it is in the API documentation, which you can download from the Forge Developers Portal. Again, somebody there asking any way to adjust the quality of the streaming dynamically based on bandwidth, and the answer is that actually yes, and that does happen automatically. That's just built into the SDK. So someone here saying you've noticed video jitters on Wi-Fi with WebRTC. It really depends on the quality of your Wi-Fi signal, how much bandwidth you have, and also how much latency you have, what kind of network you're on. So, for example, if you've got two people on the same physical network, and that physical network allows peer-to-peer connections, you will have far better quality than you will if you've got two people on the same network with AP isolation on their Wi-Fi, because that will require hairpinning things across the internet, and you then end up subject to whatever the latency and bandwidth of your internet connection is. But that's just a standard VoIP and firewall AP isolation configuration on a router issue. So how do you find the code for JS and try this app? This is from Sandra Lee. We will be sharing this presentation, so that'll be there. Says you're on device, can you make a WebRTC call over the air? This is from Roberto Tolero Sanz. I'm sorry, I can't see your full name on this screen. Yes, you can do this over 3G or 4G connection as long as you've got the bandwidth.
It's configured. You can turn that off as well if you don't want your app to be able to do that, because obviously you can use your monthly account money if you do that, so we can configure it in the configuration whether to allow that or not.
Yes, that's a good point. So actually you can make calls over 3G or 4G, you can make calls over Wi-Fi, you can also restrict that. With a question about from Yura Lapsko. I'm afraid I can't pronounce the name there. Do you have an API for Windows Phone? Unfortunately, not at this time. Yep, and another one asking for the slides and material. These will be distributed after the webinar, and so I'm now going to let Andy quickly go on and add video to the Android application.
Yeah. Okay, back to the presentation. Okay. Okay, so the next thing I'm going to do is take the original Android application and add video to it. Now this is incredibly easy because we're already connected to the Forge network. And I'm only going to add receiving video at the moment, just to keep it simple. So this is pretty much the only piece of code I need, which is you're going to call it when you connect to the SDK, and it's going to set up a callback for when you receive a video call, which is going to be an on-income session, and it's going to connect that to a WebRTC video view, which I'm going to actually put on the application screen. And again, it's going to accept the call it straight away, so it's not going to go through any ringing period, which you would probably do in a proper production app. Okay, so I'm going to actually convert the app now. Okay, so I'm going back to the original Android app. Okay, so the first thing I'm going to do is I'm going to go back to the page layout. Hopefully. I'm going to add to the bottom of that, I'm going to add the video control onto the bottom of that. So I'm going to go to video.txt. I'm actually, it's just a little bit of XML I'm going to paste into the bottom of that page. So it goes in just there. Okay, so that's one view, which is going to be the remote video, which has got an ID of video view. Another view, which is the local video, which is going to have an ID of local view. Now these are views. These are custom views that were created by us, but they actually appear. They appear in. If you want to drag and drop them on the page, then they appear in somewhere in this list. Let's see if I can find it. There is a way of searching that. Quite see it at the moment. It's in there. I'm going to show you. Okay. Right. So the two video views are now added to that page. So now I'm going to add that piece of code that I showed you into here to accept the video call. Right. So this is the piece of code that I showed you in the slide. So just test WebRTC. Put that, paste that in there. It's got a few unknown dependencies, so I'm going to add those with just the Alt-Enter key. Import class. Okay, so that's in those. Now I need to call this function when the connection happens. I'm taking a bit of code to do that. So this just calls the test WebRTC so that it sets up the callback as soon as we connect to the Acision network. Call up there. So I'm leaving the messaging part in. Okay, it's expecting a variable to store that in, so I'll put that in up here. Actually, should sort that out. That's that. So there. I think there's one other little change that I recommend making, which is if you add this to the manifest file, then it means that the activity itself handles the actual phone rotation, so that if you rotate the phone, you can keep the video going rather than it restarting the activity, at which point you have to renegotiate the video because the orientation's changed. So I'm going to add that to the Android manifest, and it goes in up there, I believe. So that means that the activity itself handles screen rotation. Okay, I think that's pretty much it. So, but this time I'm going to actually run it on a proper, rather than on the emulator, I'm going to run it on a proper Android phone. Okay. Okay. So let me just get going with this. So I'm going to try and start it. Play. Okay. Okay. So the phone hasn't found itself. It probably is asking me for permission to connect. I'll do that. It's found it. So I'll connect. Run it on the proper phone. Okay. So the application started up. I don't know whether you can see that in the webcam. I hope you can. I'm going to go back to the web page and try and call that from the web page to that Android phone. I'll just disconnect anything that's already there. And the phone is on user 0 because that's the original user that I connected as. So I'm going to call that. I'm going to accept that it wants to use video, hopefully. And then look, there you go. So that is the web page. I hope you can see that. The web page calling an Android phone. So simple video, and there's audio as well, from a web page to an Android phone. Okay. So that is basically all I'm going to demonstrate today. So that's a picture of the page. Are there any more questions? So hopefully you can see from that just how easy it is to create cross-platform messaging video apps using the SDK with a minimal amount of code. Really easy, connecting to the Forge network.
Okay, and some more questions. Is it possible to track the data usage on WebRTC, or would it have to be done separately?
I believe the web pages are going to show you their usage, and we're currently integrating some logging to do that, but I'm not 100% sure it's there at the moment. You can actually, there are Android and iOS methods you can call to monitor the WebRTC of the device, so you could do it on the client side and transmit it to a central server. There's various options. We are looking to do that in the near future.
Okay, so the questions come back again about JavaScript SDK and package all with Cordova.
I'm not sure. We haven't really looked into that a great deal. It's something that we would like to explore, but I don't know off the top of my head where we are with Cordova. It's something we can get back to you about in the future. I don't really know the current position regarding that.
So it says, for the purpose of testing, my people should have an account on your system. So the way that the Acision SDK works is that we allow, the Acision SDK can actually authenticate off of any system that you have using either a mechanism that we call simple auth or auth 2. And there are video tutorials online on YouTube to explain that, which links can be provided to you. And when you use that, you can have users on any domain that we don't even really know about, because we refer to this external system to decide whether a user is authorized or not. Just as an example, you can log on with Facebook or LinkedIn over auth 2. We use that for some of our demos. But for the test users that get created for your developer account, we just have that list of 10. And they're all on the Acision domain. So a question that Andy would best answer: how do you enable or disable audio or video when you've got a WebRTC call running?
Okay, there's various API calls you can call. When you've created a call, when you've got a call up and running, you get a session object returned to. There's an equivalent in all three of the SDKs, and there are various methods you can call on that. So you can kind of renegotiate the audio and video. You can take audio out of the call. You can put video into the call. So you can there's a whole bunch of things you can negotiate about what's going on in the call. Yeah, that's what you use to disconnect the call, for instance, that session object. So there's a bunch of things you can change.
Okay, another question from Romain Pellin: is it possible to connect more than 2 users in the same video call? And is it okay to have multiple video calls separate or not at the same time? So for the first one, I'll answer, which is that we are in the next major release of the Acision SDK network, we will have support for n-party calls where n is greater than 2. But that's not in the version that's available today.
But you can have multiple calls simultaneously, so you could have multiple separate video streams and be displaying them all on a web page simultaneously. So I could call 5 people and show 5 video tags showing all 5 people on the same page now. Yeah.
So basically, you can do sort of a mesh calling where everybody calls everybody else if you manage that logic in your application. But in the next version of the SDK, we will actually have a selective forwarding unit within the network that will enable you to make basically one call that the SDK completely manages with multiple streams. Question again, asking, do we use a turn service? And the answer is we have our own turn servers. We of course prefer peer-to-peer direct connections, and we'll use them where possible. Where that doesn't work, we use stun, and where that doesn't work, we do have turn servers enabled. Next question is it a P2P connection? And the answer is yes. It's WebRTC. Peer-to-peer is the default. followed by stun, followed by turn.
So the video call doesn't, unless it's turn, it doesn't actually go through any of our servers at all, is the idea.
Yeah, and even when it does, it's encrypted using DTLS SRTP, so we can't actually decode it. Comment on scaling. Can we comment on scaling with WebRTC?
Is this like video resolution scaling or scaling? I'm not quite sure what scaling that's referring to. Is it scaling with multiple channels simultaneously?
If you're meaning, yeah, I mean, I'll assume that you're meaning a large-scale service, and the answer is WebRTC scales very well, because by default things will be peer-to-peer. When they're not peer-to-peer, they'll be using stun where possible, which is pretty much peer-to-peer, and we only fall back to using a turn server when we have to. So it does scale very well.
And we run our turn servers in a cloud environment, so we can actually scale the number of turn servers we have potentially to actually compensate for higher loads.
Okay, yeah. So scaling into conference calls with multiple parties. Yes, I've seen the next couple of questions there. So yes, the selective forwarding unit technology we're looking at can scale to very large numbers of participants. But right now, basically, you scale. You conference or you have multiple parties by creating multiple video sessions on each one, which means that if you have 5 people in a conference call, each of those 5 people has to have 4 calls up. So your scaling from a software point of view isn't hard, but it will have an impact on bandwidth and processor usage of your system. So somebody said, how can we integrate this application into our own project? Well, Andy?
Yeah, I mean, that's exactly the kind of thing that we're aiming for with this SDK. It should just be a matter of dropping in the libraries and using them where appropriate in the activities you want to use them for. I mean, that's kind of, we have looked already at adding them to existing projects, so yeah, should be possible.
Okay, another one from Romain. Can we control which camera, front or back on iPhone, is used for the video?
Yeah, there's an API call to say which camera you want. I believe you get a list of, I think you'd say front or back. There's basically a method you call to say which camera you want to use.
So somebody commenting for something like Google Hangouts. So Google Hangouts basically works using a selective forwarding model. That's what we will support in the next version of the SDK. But for right now, today, when you're wanting to create something like that, you have to create multiple sessions from each device. Okay. Yeah. So So another question, about controlling the media. Can you disable or enable your local audio source, your local video source?
Yeah. You can turn it on and off as you go through the call. You can renegotiate the call.
Okay. Another one from Joseph. Is it possible to receive feedback or votes from different users that you are broadcasting to them? Yes, because the messaging that you see that Andy used, which is being displayed on screen, you can actually send anything you want using that messaging between yourselves or to other between yourselves. If you want to send a JSON object to someone, you could just set the content type to application JSON, and you set the content disposition, something that informs your receiving application that this is to be used for feedback calculations. And then you don't have to use the instant messaging just to send messages to people. Do we use Socket.io? We don't, I believe.
No, we don't use Socket.io.
So it says, can you modify the SDP like on the Google Hangout made by video? No, developers using the SDK cannot modify the SDP very easily. That's deliberately kept.
Yeah, they can modify fields that are in the SDP by setting up constraints and things like that, so you inadvertently modify it, but SDPs are quite complicated to modify, so we've tried to simplify it by adding a layer on top of that. So. Okay, so a question about scaling of video from Romain Pellin again. Will the Retina display be more network hungry? The answer is that
basically the WebRTC libraries by default will attempt to use up as much bandwidth as is available to provide the best quality picture, and will downgrade as required to maintain as good a quality picture as possible. But by using the constraints that have been mentioned a few times, you can limit what the application will do. So what library do we use for signaling? We use a variety of different signaling libraries. We basically use SIP for signaling, but we use a number of different libraries for SIP across different platforms, and in a number of cases we've made some modifications ourselves. Our background is actually as signaling engineers here. Can you record the video chat? So you could do it locally on your device by recording the streams. Recording on the network is, again, it's a feature that's due for the next major release of the SDK and will come alongside the conferencing support.
So basically the next few months.
Yes, in the next 2 to 3 months that will be available, perhaps sooner, for some beta customers. Yes, you could do local recording right now. So do we have a tutorial for many-to-many video calling on the platform? No, not at the moment, but that's a good idea, and we'll add that to the list and hopefully have one soon. And that's all the questions so far.
Okay.
So okay. So just to finish off, there will be another webinar on the 29th of January, and what we're going to try and focus on in that webinar is answering any common or interesting questions that people come up with between now and then. The submission date for the hackathon is 8 AM GMT on the 19th of February, and you can register for the hackathon at a URL that's on screen. If you've got any questions, please send an email to Maud. Her address is there, maud@bemyapp.com. And like I said, in the next webinar, what we will do is rather than develop apps, we will actually focus on providing answers and tutorials for specific points that people have come up with and ask us between now and then. Thank you very much. I think that's everything from us.
Thank you very much. See you soon. Bye-bye.